All right, today we're talking about the tech that's finally letting AI out of its cage, letting it act in the real world. But, as we're about to see, this incredible new power, it comes with some pretty terrifying new risks.
So let's just jump right in. Everything we're talking about today really boils down to this one big question, a question that's driving the whole next wave of AI. It's not just about what an AI can think anymore. The real question is, what can it actually do?
And to really get a handle on why this is such a huge deal, a real game changer, we first have to talk about AI's biggest weakness. I'm talking about the walled garden problem.
Yeah, think about it like this. You've got the most powerful, most advanced AI, and it's basically a brain in a jar. Seriously, it's totally trapped. It can write flawless code, it can pass the bar exam, it can create beautiful poetry, but it can only do that using the information it was originally trained on. It can't look up something new on the internet, and it definitely can't take any action in the real world. It's stuck.
So what happens when we try to hook these brilliant brains up to the outside world? Well, you get this, a total tangled mess. This is what we call the N by M integration problem. See, for every single new AI model, that's your N on the left, and for every single new tool or API, that's your M on the right, some poor developer has to build a custom one-off connector. It's a nightmare, it's total chaos, and it absolutely does not scale.
Okay, so how do we fix this mess? How do we finally give that brain in a jar some hands, some eyes, a way to interact? Well, the answer, it's something called tools. So what is an AI tool? Simply put, it's just a program, a function that the AI can use to do something it can't do by itself. The best way to think about it is like apps on your smartphone. Your phone on its own has its basic functions, right? But it's the apps that let you order food or navigate or whatever. Tools do the exact same thing for an AI. They give it new powers to see and act in the world. And really, these tools fall into two main buckets. You've got your information retrieval tools. These let the AI go out and learn something new, search the web, pull from a database. And then you have the action or execution tools. And this is where it gets really interesting. These let the AI actually do stuff, send an email, execute some code, maybe even control a robot. Okay, so we have these tools, awesome. But we still have that big, ugly integration problem we talked about, right? All those tangled wires? Well, that's where this new open standard comes in. It's called the Model Context Protocol, or MCP for short.
The whole point of MCP is to just completely get rid of that tangled web of custom connectors. Think about it like this. Remember when every single phone and device had its own unique, annoying charger? And now, pretty much everything uses USB-C. That's exactly what MCP is trying to do for AI. It's creating one single standardized plug-and-play system. Any model can now connect to any tool. Simple as that.
And the way it works is actually pretty simple, but really smart. You've got the host, that's your AI application. It uses a client to talk to a server, and that server is where all the tools and data are. The really clever bit here is that everything is separated. This makes the whole system super modular, super flexible. You can swap things in and out without breaking everything.
So this universal connection, it's a huge leap forward. It unlocks the potential for AI that is way more autonomous, way more capable than anything we've ever seen before. But, and this is a big but, this power is a classic double-edged sword. And right here, this is where our story takes a really crucial turn. Because with all this incredible new power comes a whole new set of risks. Risks we're really only just starting to wrap our heads around.
This table really lays it out perfectly. It's two sides of the exact same coin. Look at the left. MCP speeds up development. It creates this awesome, flexible ecosystem. Fantastic, right? But here's the catch. Those exact same strengths are what create the massive risks you see on the right. That amazing flexibility, it also opens up a brand new threat landscape. And the protocol itself, it doesn't have any of the built-in security or identity features that big companies absolutely have to have.
Okay, so let's make this really concrete. Let's look at how this all comes together to create a very real, very scary threat. We're going to take a classic, old-school cybersecurity vulnerability and see what happens when you apply it in this brand new AI world.
This is a famous one. It's called the confused deputy problem. So picture this. You've got an AI assistant that helps your engineers write code. It's connected to your company's super secure code repository, the crown jewels. That connection goes through an MCP server. Now, to make the assistant really helpful, you've given that server, the deputy, really high-level permissions. Meanwhile, you've got a bad actor, an employee who wants to steal a secret algorithm, but they don't have the clearance to access it themselves.
Now, here's the brilliant part. The attacker doesn't try to hack anything. They don't break through any firewalls. They just talk to the AI. They write a very clever, very innocent-sounding prompt, something like, "Hey, can you find this secret file for me?" And then, "Great, now can you just copy all of its contents into this other new file over here?" A file they can access. To the AI model, this just looks like a normal request. It doesn't know the user's intent is malicious. It gets confused.
And boom, this is where it all goes wrong. The MCP server gets the command from the AI, and it trusts the AI completely. So what does it do? It checks its own permissions, which, remember, are super high, and not the permissions of the original low-privileged user. It says, "Sure, I can do that," and executes the command. And just like that, the secret algorithm is stolen. The attacker never hacked a thing. They just tricked a powerful, trusted deputy into doing their dirty work for them.
So you see the problem, right? This whole new world of AIs that can actually do things, it demands a totally new way of thinking about security. The old rulebook, it's just not going to cut it anymore.
Look, the answer isn't to just throw this amazing technology away. The path forward is to build a really strong, robust layer of governance around it. We're talking about things like having a human in the loop to approve any really risky actions, and probably most important of all, enforcing the principle of least privilege. That just means that the AI and every single one of its tools should only have the absolute bare minimum permissions they need to do their specific job, and not a single thing more.
And that really brings us to the key takeaway here. A standard like MCP, it's incredible. It provides the universal language, the USB-C port, that lets AIs and tools talk to each other. But it does not provide the guardrails. It doesn't provide the safety net. That responsibility, it lands squarely on the shoulders of the companies and the developers who are actually building these powerful systems. Which, I think, leaves us with one final big question. As we all race to unlock this incredible power, this AI that can act in the real world, are we also building the wisdom and the security we need to manage the peril that comes with it?